number one. Okay, if you're looking at this parallelogram, so the big idea is these lines are parallel. These markings are what you got to pay attention to. Top and bottom are parallel, left and right are parallel, and then looks like these diagonals are bisecting each other. So this piece is congruent to this piece, so that must be the midpoint. And then this piece is congruent to this piece, so that must be the midpoint. So which statement helps prove the triangle ABD? So I'm going to draw a triangle ABD. Triangle ABD is this triangle right here. ABD is congruent to triangle CBD, and CBD is this triangle right here. CBD. So you do not know that the top is congruent to the bottom, and you don't know that the left is congruent to the right, but we do know that this DB is congruent to DB. That's the same piece, so we know that. Now, because these are parallel lines, if I look at this as a transversal right here, and these are my parallel lines, whoops, I know that this angle is congruent to this angle because they're alternate interior angles. So this angle right here is congruent to this angle right here because they're alternate interior, and the same is true for this angle. That's the same as that because they're alternate interior. So this angle right here is the same as this angle. So we're gonna go with D. Alternate interior angles formed by parallel lines and a transversal are congruent. So I've got, what do I got here? Two angles are congruent, and this side is congruent, so angle, side, angle. Okay, number two. Okay, this one's kind of a tricky one. We haven't done any of these, but maybe some street smarts can get you the right answer. So A is at 4 and negative 5. B is at 16, negative 2. And they're going to position C somewhere. They're going to put C somewhere in between A and B so that the ratio of A to C and C to B is 5 to 7. Okay, now I'm just going to think of this X number line. So I got A right here, and I got B right here. Okay, now the distance between A and B. A is at 4, and B is at 16. So the distance between 4 and 16, just on this number line, is 12 units. So we're going to drop C somewhere in between so that it's a ratio of 5 to 7. Okay, now if I put C right here, and if I go 5 units from A, so 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, from here to here is 5 units. This is number 9, and then 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15. So it works out from here to here is 7 units, because 5 and 7 is 12, and the total distance is 12. So it's got to be some multiple of a ratio of 5 to 7. Could be 10 or 14, 2.5, 3.5. But it just happens to work out. This ratio of 5 to 7 works just nice. So the X coordinate has got to be 9. So we're going to go with B. Three, what is the least amount of information needed to show that two triangles are similar? One side and one angle. Okay, remember you need this. You need like side, 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 angle, side, or you need, oh no, that's congruent. Okay, similar means this. Similar is a whole different thing. Similar means it's the exact same shape, but the size is different. So these two guys right here, they can be similar. They're the same exact shape. They're just different sizes. So if I take, and I guess they don't even look like they're the same shape. So if I take an image, now if I copy and paste this, copy. Okay, now these two are the exact same shape and size. They're congruent. But if I take this one and I make it bigger, now they're only similar. So similar is the same shape, different size. Similar though, the angles are congruent. That angle is congruent to that angle. This angle right here is congruent to this angle. Even if you change the size, the angles do not change. That's what preserves the shape. So all we need, the least amount of information, is we need to know that two angles are congruent. So if this bottom left is congruent to this bottom left, the bottom right is congruent to the bottom right, that means by default the third one has to be congruent to the third one. So similar is same shape, just different size. Congruent is same shape and size. Okay, this one's kind of tricky. You gotta draw the correct picture. So Xavier cannot walk from A to B because there's a pond in the way. Instead, he starts walking at an angle of 30 degrees off the path, then makes a 90-degree turn. So something like this. Here's Xavier right here. If he makes a 90-degree turn, that means he's got to hit a perpendicular. So that means the pond must be right here. So he cannot go straight to the pond. So that's got to be a 30-degree angle. So we'll call this A, we'll call this B. There's my 90. This piece is 40. And this is a special triangle. This is a 30, 60, 90. And they'll probably give you some 30, 60, 90, 45, 45, 90s. So because this is a 30, 60, 90, I'm going to draw the whole picture. So the whole triangle looks like this. So there's a 60 and there is a 60. So on a 60, 60, 60, all sides are congruent. So that's 80, and this is 80. And the question is, the direct path from A to B, if he could walk it, is 80 feet. Okay, number 5. I think this is more like 8th grade math, so we're just using proportions. We need to find this building, the shadow of the building and the shadow of the tree. So let's use this. The flagpole and its shadowed. So 12 feet is to the shadow, 3.5. As now, because I did height and shadow, I got to do height of the building. 30 is to shadow, that's x. And then if you got a proportion, you just multiply these two and divide by 12. So 30 times 3.5, divide that by 12. So this is 8.75. So 8 3/4. And then the tree is going to be the same thing. 12 is to the shadow, 3.5 as the 18 is to x. So now 18 times 3.5, divide that by 12, and this is 5 1/4, 5.25. Okay, 6 is kind of tricky. So this guy right here is phi. So it's a letter from the Greek alphabet, and it's right here. This is where you need to look. So sine is, you got to remember the trig, so katoa. So sine, this 3 must be the opposite, and the 5 must be the hypotenuse. The problem is, with this phi, there is no triangle. So we're going to make one. At this intersection, we're just going to go parallel to this guy, and we're going to make a 90 degree. So now this is the triangle you're looking at. This is what you need to do. You need to insert a side. So opposite of phi is this piece right here. So this piece must be 3, which means this piece is 3, which means this piece is 3. And then the hypotenuse, that's opposite the 90. So my hypotenuse is right here. That is 5. And this is a Pythagorean triple, the most famous Pythagorean triple. So if you were to find, let's say we have to find this using Pythagorean theorem, if you didn't recognize it was a triple, we do leg squared plus leg squared equals hypotenuse squared. So 9 plus x squared is 25, minus the 9 minus the 9, x squared is 16. square root, so x is 4. So that means this guy is 4. So that means this guy is 4. Now they want you to use the information to find the cosine of theta. So cosine is the ca, that's adjacent over hypotenuse. Now you're looking from theta. The adjacent is going to be this piece right here, 3 over 5. And we're going to go with B. Okay, 7. Let's skip to 10. Let's do 10 first. Okay, now 10, and then we'll come back to 7. Here is what we're going to do. We're going to start doing trig in the coordinate plane. So in your coordinate plane, let me just give you a quick example. You always start at 0, 0, and you put this piece right here. This is called your initial side. It's going to lay right on the x-axis in the positive direction. So if I wanted to ask you like the tangent of 30 degrees. So you got this piece laying down flat. Now you're going to open up until you hit 30 degrees, and then you're going to stop, and then you're going to make an angle coming out here. So that's 30 degrees. Okay, now if you're going to do a trig on this, you're going to make a triangle. You always drop perpendicular to the x-axis, and here is your triangle. Now the dimensions of it don't matter. So because it's a 30, 60, 90, I'm going to say all sides are 10. That's 10. Here's my other half, the ghost half. That's 10, and that's 10. So that means this piece is 5. But now because we're in the coordinate plane, this piece is a negative 5. Because anything going below 0 is negative. Then this piece right here has got to be 5 square roots of 3. Okay, now tangent is the TOA. So here's where you're looking from. This is theta right here. So opposite is going to be 5 over adjacent. That's going to be 5 square roots of 3. So I'm just making this up. I just made up this tangent 30. So 5 divided by 5 cancels, times the bottom by square root of 3 times the top by square root of 3. So your final answer is going to be square root of 3 over 3. Okay, now in the coordinate plane, you got to think of a bow tie, because your triangle in this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. In quadrant 1, that's where we've done most of our trig. And this is what the triangle looks like. But now we're going to move over into quadrant 2, 3, and 4. So it just looks like a bow tie. If you reflect this triangle across the y-axis, it's going to come in quadrant 2. This is what it's going to look like. And then you just flip this over the x-axis, and it just makes this bow tie looking shape. So if you remember the bow tie, that's all you need to know. That's what each triangle looks like in the quadrants. So let's look at 10. 10 is telling you that it's in quadrant 2. So it's going to be this triangle right here. Here is theta. Theta is always the angle attached to the origin. So if we're in quadrant 2, this is the triangle you need to look at. So the sine, that 4 is the opposite, and 5 is the hypotenuse. So here's my hypotenuse right there, that's 5. The opposite is 4, that's this guy right here. And we just did a 3, 4, 5 Pythagorean triple. So this piece is going to be 3. But because we're going left of 0, we're going in a negative direction, that's going to be a negative 3. So in the coordinate plane, now you start to get some negatives. And they want the cosine. Cosine is the adjacent over the hypotenuse, so this is the adjacent. It is going to be a, it's negative 3 over 5. Okay, now let's go back and look at 7. Okay, 7. They're telling you that the tangent is negative, and the sine is square root of 2 over 2. Alright, so let's look at this guy right here. If I started off in quadrant 1, which is where we've done all of our trig. Here's theta right here. So the sine is opposite, that's opposite, square root of 2, over the hypotenuse, that's 2. Okay, let's figure out this missing piece right here, and we can just do Pythagorean Theorem. So I know that's my 90, this is my hypotenuse, so I'm going to do leg squared, square root of 2 squared, plus x squared equals hypotenuse squared. Square root of 2 times square root of 2 is square root of 4, which is just 2, plus x squared equals 4, minus 2 minus 2, x squared equals 2, square root, so this piece is also a square root of 2. Okay, so that means this is if my two legs are the same, this is half of a square. This is a 45, 45, 90. Okay, now tangent, here is tangent. Tangent is the TOA, so it's opposite over adjacent. So right now my opposite is positive and my adjacent is positive, so it is not quadrant 1. Let's flip it over into quadrant 2. If it was in quadrant 2, it would look like this. Okay, that would be that would be the hypotenuse, so that would just be 2. This would be square root of 2, and this would be square root of 2, but this would be negative because I'm going left of 0. So opposite over adjacent would be square root of 2 over negative square root of 2, and that would just be a negative 1. So tangent is negative right here in quadrant 2, so that's my answer. Sine is positive because the sine is opposite over hypotenuse, so opposite over hypotenuse. Sine is positive, but tangent's negative. That only happens in quadrant 2. Okay, 8 is wrong. 8 copied wrong. Okay, this piece is the piece shown right here. And this is actually A, and then B looks something like this. This is 12, this is 12, this is 6. So copied wrong. So number 8, identify the triangle that is similar to the triangle shown. Okay, the trick on this one is this is the smallest piece, this is the medium piece, and this is the large piece. So let's compare small to small, medium to medium, large to large. So on 8, if I go small, let's do it with C. I'm going to do 6 with 12, the smallest, and 12 is the smallest. Now I'm going to do the medium. 9, and the medium here is 15. Then I'm going to do the medium, or the largest, 12 and 18. Okay, now these fractions all got to simplify to give you the same thing. 6 twelfths is 1/2, 9 fifteenths is like 3/5, and 12 eighteenths is like 2/3. So it is not C. Cannot be C. Okay, now let me do D. So the smallest, 6, and the smallest on this one is 4. The medium on this one is 9. The medium on this one is 6. The largest on this one is 12. Largest on this one is 8. If I simplify these, that's going to be divided both by 2. That's going to be 3/2. Divide these both by 3. That's going to be 3/2. Divide these both by 4. That's going to be 3/2. 3/2, 3/2, 3/2. So it is D. These two are similar, so that means they're the exact same shape but just different size. Okay, number 9. 2 triangles have 2 pairs of congruent angles. What must be true? So if the angles, 2 pairs of congruent angles match up, that is only 1. So it's A. That means they're similar. That doesn't tell you anything about their size, that only tells you about their shape. 10, 11, okay, we have not done 11. then I'm not even sure what to tell you about 11. Maybe we'll save it for the very last. Okay, let's do 12. We haven't really talked about 12. Which property is sufficient to prove that a parallelogram is a rectangle? Okay, something about rectangles is their diagonals are congruent. So if you have something and this diagonal is 10 and this diagonal is 10, that means that the top is congruent to the bottom and the left is congruent to the right. That means they're also 90 degrees right here. It means it's a rectangle. So we got 90, 90, 90. So in a rectangle, their diagonals are congruent. 13. Okay, you gotta draw a picture. So segment AB. So you just draw a line. Here's B. Here's A. C is right in the middle. So C is right here. That means this piece is congruent to this piece. They're the same size. A line through C that's perpendicular. So this is a perpendicular. That means that's 90. Extends to point D. So we'll call this point D. Okay, what do you know about AD? So AD is a line from here to here, and BD is a line from here to here. So here's what you got. Which one of these four can you use to prove that AD is the same as BD? So you've got this side is congruent to this side. You got this angle is congruent to this angle. And then you got this side, CD, is congruent in the left triangle to this side in the right triangle. So we got side angle side. So we're going to go with C. So if we got side angle side, that means these triangles are congruent. That means this side must be congruent to this side. Okay, 14. So this is another trig in the coordinate plane. So let's draw the coordinate plane. Okay, now quadrant 4. That's 1, 2, 3, 4. So it's going to be right here. Now remember your bow tie. So if it's in quadrant 4, this is the one right here you're looking at. So you're going to go over, you're going to go down, and you're going to go up. And there's my 90, and here is theta. Okay, so the cosine is 2/3. Cosine is adjacent over hypotenuse. So the adjacent is this one, that's 2. And the hypotenuse is 3, so we got to figure out what this is. So let's do Pythagorean Theorem. Let's do 2 squared plus x squared equals 3 squared. So now 4 plus x squared equals 9 minus 4 x squared equals 5. So square root x equals square root of 5. But it's got to be a negative square root of 5 because we're going below 0. We're going down towards negative infinity. So it's got to be negative. Okay, now they want the tangent. Tangent from theta. Tangent is the TOA. So that's the opposite over the adjacent. So opposite is this one. Negative square root of 5 over the adjacent. That's 2. So we're going to go with C. Okay, 15. Drag and drop which ones are true. If I drop this right here, cosine of A. Cosine of A, that means I'm putting theta right here. That means this is the adjacent and this is the hypotenuse. So cosine of A equals the star over the square, adjacent over hypotenuse. That is the exact same thing as the sine from B. Now the sine from B means I'm going to put theta on B. So if I put theta on B, sine is opposite over adjacent, and opposite is across, opposite over hypotenuse. Opposite is the star. So the sine of B is the star over the hypotenuse, which is the square. So they're the exact same fractions. So cosine from one angle is the same as the sine from the other. So we can put, what else can we put? So we used cosine of A, sine of B. We can do cosine of B. Cosine of B is going to be circle over square. And sine of A is going to be opposite over hypotenuse. This is going to be circle over square. So sine of A. And then 16. Okay, these two lines are parallel. So this line right here is parallel to this line right here. So here's what we know. This angle is congruent to this angle because they're a vertical pair. Now this angle right here is congruent to this angle right here. And this angle right here is congruent to this angle right here because they're alternate interior angles. So now let's figure out Oak Avenue. So let's set up a proportion. Let's compare, so this little triangle on top and there's kind of a bigger triangle on bottom. Let's compare the little to the big. So let's put 352 on top. 352 on top, and on bottom that corresponds with this piece right here, 484. So the big triangle goes on bottom, and I'm going to put this on the bottom right here. Now the question is, which street does Oak correspond to? Does Oak correspond to 312, or does Oak correspond to 264? And you have to use the math. So look at where Oak is. Oak is in between the 1 and the 2 marks. So in between the 1 and the 2 marks is 312. 312 has to go here. So this triangle, if you put a nail right here in this intersection, then you got to rotate this. You got to bring this 312 and you got to swing it down. And then it's oriented the exact same way as this big triangle on bottom. So you have to look at your congruence marks. Oak Avenue is between the one with 2 congruence marks and 1 congruence mark. So that means you got to look at the street that's between 2 congruence marks and 1 congruence mark. So it's got to be 312. So now multiply these two and divide by 352. And your answer is 429. So that means it's 429. Okay, now let's maybe go back to that circumscribe. Alright, a circle circumscribes a triangle. So that means this. On your coordinate plane, if you've got a vertex at 0, 3, so 0 up 3, there's a dot. Over 4, 0, there's a dot. And then 0, 0, so your triangle looks kind of like this. Now if a circle circumscribes it, what that means is we're going to put a circle that touches all 3 vertices. So this triangle is going to fit right inside the circle, and each of the vertices is going to lie on the perimeter of the circle. So it's easier to show in GeoGebra. So let me move over to GeoGebra and show kind of how to do this. So I guess there's 2 things that might show up. Circumscribe, that's circumscribe. If you were to put inscribe, so if we have a triangle right here and you're trying to inscribe a circle, that means you draw a circle on the inside. Circumscribe means you put it on the circumference or on the outside of the triangle, but inscribe means you put it on the inside. So those might show up. Okay, now in GeoGebra, let's do a new file, maybe. maybe not. Alright, okay, I think I got one ready. So I'm going to put a dot on 0, 0, on 4, 0, and then on 0, 3. Okay, now let me get rid of these. Okay, so now I'm going to connect the dots. So if I go here to here, here to here, and here to here. Okay, now if I want to circumscribe a circle, I need to find the circumcenter. And the circumcenter is, you take this line and you do perpendicular bisector. So perpendicular bisector, that's this guy. So I cut this line in half at a 90. There we go. Then I cut this line in half at a 90. And then I cut the hypotenuse. You cut all three of them in half at a 90. And where they meet, right there, that's called the circumcenter. So this is going to be the center of my circle. So now if I get a circle, and I center it right on that circumcenter, it will catch all three of these vertices of the triangle. So to find the circumcenter, you got to find the perpendicular bisector of each line. And it wasn't bad because it gave you this 90 degree right here. So we got to find halfway between here. Where's my writing tool? So this was 0 and this was 4. So this dot right here is at 2. Okay, now going up and down, this was 0 and this was 3. So this was halfway between 0 and 3. So this is 1.5. So I'm going to go over 2. I'm going to go up 1.5. And that matches with either C or D. Because C says over 2 up 1.5. D says up 1.5, over 2 up 1.5. So now we just got to find the radius. And the radius is going to be, what is the radius of the circle? So the radius is going to be the distance from here to here. So here's what we got to do. Whoa, that's not what we got to do. Okay, your radius right here is the circumcenter. So your radius is the distance from here to here. So if we find the distance from here to here and cut that in half, because this is the diameter, and that's the length of the hypotenuse. So we got to use some Pythagorean Theorem. So along this base right here, it was 4 and this was 3. So that means this is 5. So it's a Pythagorean triple, 3, 4, 5. So the diameter is 5, so the radius is going to be 5 halves. So we're going with D.